My name is Kafui Dake, and I'm the IT manager for the AIMS Global Network. A brief background about AIMS. We are the African Institute for Mathematical Sciences. We have 5 centers of excellence in 5 different African countries: Rwanda, Ghana, Cameroon, Senegal, and South Africa. The short version of our mission is that we believe the next Einstein will be African, and we are creating the right environment to discover the next Einstein. I'm going to focus on two key issues, 2 key insights we've learned from our use of AWS for not just our online learning, but for our general systems and infrastructure. The focus here is on storage, and Adi did a great job talking about the various storage options available in AWS. So in our case at AIMS, we had a very specific problem. We had quite a bit. We began moving to the cloud aggressively in 2018, and before that, we had a lot of our services running and our workloads running in our data centers in Kigali, in the various host countries. And so we started to do two things. We started to centralize much of this infrastructure and avoid the complexities and cost of duplicating this infrastructure across 5 different countries. We started to centralize them, and then we started to move them to AWS. The problem we encountered once we started using AWS is that while it looks attractive in the beginning because it's very quick to spin up instances you just take a credit card and spin up instances, it quickly gets expensive, especially the way we were doing it. What we were doing is basically lifting and shifting. So we were taking our applications and moving them to AWS in a cloud agnostic manner. So we didn't take advantage of any of the cloud native, just looking at this chart, we didn't take any advantage of the cloud native options available to us, and that turned out to be expensive really, really fast. And AIMS is a 100% donor funded institution. We are non-profit, and cost is a really big factor for us. All right, so we started looking into what to do regarding cost. And there were 2 big areas, storage and compute. So we'll talk about storage first. And we realized that AWS offers an object storage service called a simple storage service, S3, that was well suited for most of the workloads we're running. AWS is an object storage service, so it's not your traditional file system. In fact, the claim is not really a file system per se. And one of the immediate things you notice about S3 is you can't edit anything in S3. If you put something there and you want to change it, you have to delete it and put a new version there. So that's one thing you should be aware of. So there are costs, but apart from that downside, once you get used to it and work around it, it is a fully managed service. It's serverless, so you don't manage any servers. And it is extremely low cost compared to the other storage services available in AWS. So I'll say, for instance, the traditional storage class, the block storage class, Elastic Block Store, which most people use when they spin up a Linux or Windows instance on AWS, costs almost 6 times more than S3. And that's no mean savings. So that's something we are particularly interested in taking advantage of. S3 is almost infinitely scalable. So you can put as much data as you can into it without worrying about running into data storage limits. All right, and it's the best uses we found for S3 at AIMS is things like backups, archiving, and data lakes. So for some of our research groups, they use S3 as data lakes, and then cloud native applications. So I've already talked about how we are very cost sensitive, and we were worried about costs. We were paying We're paying about more than 3,000 USD a month for AWS combined, or combined AWS bill was about $3,000 a month. And we needed to bring this down fast. So the first thing we did was look at what we're using the storage for. And we have something like 30 web applications spread across multiple Linux and Windows instances. And when we looked at the data, a lot of the data was what we call infrequent access. So once it's created, it's not accessed frequently, and it doesn't change much. So for instance, we have a student recruitment portal, which runs on AWS, and we use it sometime between November and March for student recruitment. And a lot of the stuff is students applying for various programs at AIMS, uploading documents to support those applications. And once those documents get into our system, they just stay as is. Nobody goes back to edit the PDFs or the transcripts and stuff that they have uploaded. And this made that class of data a very, very perfect target to move it out of a block storage and into object storage. It was not a straightforward path though, because you have to change your application to work with object storage. It's not something you can just point and click. You have to change the way your application logic works, and you have to rewrite portions of the application to take advantage of S3. But once you do that, it's very, very cost effective and very, very easy to maintain. And if we can get if we can reduce our bill by up to a factor of 6, that's a very, very good reward for the effort involved in rewriting some of these applications. The other majority of the other half of our workloads were mostly standard web applications, like running on WordPress and some custom content management systems. Luckily for us, there is quite a lot of work has already been done on how to take the static components of WordPress and move them to S3, because WordPress essentially, and most content management systems comprise a database, some static content, and so it made it moving the static part, so stuff like pictures that are uploaded, theme files and stuff that don't change frequently, moving them to S3 also helped us to reduce the amount of storage we're using on EBS. Because remember, EBS, the block storage, is very, very convenient. It works just like a normal file system in your server, in your data center. It is directly attached to your instance and SSD backed, but it's expensive, very, very expensive compared to S3. So S3 became the savior for us when it came to cost, and we are continuing to explore and take better advantage of S3, because S3 has multiple classes. The standard class is about 6 times cheaper than EBS, but S3 also has other classes like infrequent access, Glacier, where basically S3, Amazon allows you to say 70% of my data is not accessed frequently. So you can store it in, say, cheaper storage in your backend, so that to give and pass those savings onto us. It gets even much cheaper when you're talking about things like S3 Glacier, because these are stored in cold storage. So you would have a 2-hour lead time from the time you need, you request the data to the time you get the data. So someone actually has to go and restore the data for you. But then the advantage is that you get very, very cheap, very, very low cost in storing your data. The other thing the other cost driver for us at AIMS was the compute. So we had several instances. We tried to size them as small as possible. And the problem we had was we were paying on demand, which is a very, very, very bad practice. We started off with on demand because when we started the migration, because we were not sure about how it will go, and we didn't want to make any huge commitments. But once we became comfortable enough with AWS, we switched all our instance purchases to reserved instances. Reserved instances in AWS is basically a billing feature where you can pay in advance for a certain capacity. So if you have an instance with 2 GB or 2 cores, for instance, instead of paying on demand for it, so you're charged by the hour, you can pay either 1 year in advance or 3 years in advance. So you actually make a commitment. You don't have to pay everything upfront. AWS has different options available. Paying everything upfront gives you the most savings. You can get up to 75% savings relative to on demand if you go with instance reservation. So you can look at your workloads and you know which ones are not going to change much and reserve the instance. That will give you up to 75% cost savings over just doing on demand. The reservations can also, there are also options, flexible options there. So some people still want to pay a monthly bill, you can do that. And the standard reservation doesn't allow you to change your capacity until the reservation period is over. But there are convertible reserve instances where you can, for instance, change the type of instance. If you had a smaller instance and you wanted to go up, or you had a bigger one, you wanted to come down. If you want to have smaller one, you want to go up, you can change that. If you want to change from one type of instance to another type, because AWS has different types of instances for different applications. So they are general purpose, there are some just for machine learning, and some that are memory optimized, and so on and so forth. These two brought our AWS bill down by 50%. So simply by moving our static content as wherever possible to S3, and then reserving instances, we went from $3,000 a month to about $1,300 a month on AWS. And our goal is to keep driving that down as we discover more and more cost-saving issues. There's a certain point where you have to put in quite some additional effort to change your infrastructure and change your applications to take better advantage of AWS. And this is where the last item on this slide is really important. We only started seeing savings from AWS when we started investing in capacity development in the IT team. So the problem with AWS, and very likely with Microsoft Azure and Google Cloud, is they throw a lot at you at once and let you figure it out yourselves. Unless you are a big customer like ASU and you can get a personal solutions architect to help you work through everything. But AWS offers certification and certification paths, which are very, very useful. The exams are not too expensive. You can invest in training and certification for your staff. This is really important because AWS, as I said before, is very flexible, it's very scalable, but it can get very, very expensive if you make the wrong decisions in the beginning. If you set up your architecture the wrong way, you end up spending more money than you should be spending. And about the only way you can make any sense of AWS is to invest in capacity development. It's a constantly moving target because they keep launching new products and features. And so you have to make a determined and active effort to make sure your staff are up to speed on AWS or Azure or Google Cloud, whichever you're using right now. We are using AWS. One thing that I've seen, KNUST is already on AWS just like us. It's easy when you go to AWS at first to just put everything in one region and everything in one data center, or what AWS calls availability zone. You should resist that and take the time to make your applications a bit more resilient by splitting them across multiple availability zones within your region. There are a lot more things you can take advantage of, such as managed services like load balancers. But all of these require you to have the capacity to understand and implement these. And advice, if you've not started yet, start small. First look at what you are doing with your on-premise data centers, and if you already have something in AWS, what you want to take to, what you have there and what you want to take there. Understand what you're doing, because if your data is highly dynamic and changes a lot, and it's not as static as some of our most of our workloads are, then you have a problem. But if you take online learning as an example, a lot of the content will be static. Your videos and stuff will be static content, and you will be accessing them more than you are modifying them. So start small. Don't bite off too much so that it doesn't get frustrating. And make sure you understand your workload, and make sure you do not skip the investment in your staff capacity development. I see an issue about budget. This is an issue we understand very well at AIMS. It's one of the reasons why capacity reservations are very attractive to us, because you can lock in your capacity for a year or 3 years in advance, which allows to skate around this inconsistent budget funding issue. So you can make the business case and then lock in this capacity for 3 years, for example, and then only have to worry about it once the 3-year cycle is coming to an end. That's one thing we are doing at AIMS. We also, as much as possible, are trying to avoid monthly payments, not just because of funding, but because of workload, the procurement, the paperwork involved in making payments monthly. So as much as possible, reserve capacity in advance, reserve storage in advance. This is why you need to understand your workloads. S3, thankfully, is a pay as you go. You only pay for the data you store, and you don't pay for the most part, you do not pay for accessing your data. So if you had a file on the S3 and somebody downloaded it from the web, in general, you do not pay for that. You only pay for storing the data for a certain amount of time. You do not pay for traffic, you do not pay for accessing the data within certain limits. So if you're within the same region, if your applications are within the same region, traffic is free, and accessing it from the internet is also free.